Hello, everybody. Thanks for joining us. This webinar is focused on QPS's innovative new workflows for today's hydrographic office. And first, a little bit of information about the webinar today. This is brought to you by the US team, myself, Matt Wilson as presenter, with Samantha Bruce, technical sales engineer, and Chris Malzone, general manager. They're both in the background for support and to help answer questions. And before I get too far into this, just want to make sure that you can hear me okay and that you're seeing the screen okay. Sam, if you could verify that for me.
Everything looks good, Matt.
Okay, thank you very much. All right, so we have both slides and demonstrations. The slides to introduce and then the demos to showcase the functionality. And we're using some heavier data today, at least in the first demonstration. I know it's a lot easier to have a smaller data set to use for these, but I understand that that likely is not totally representative of what you are working with every day. I know this, I'm from the field myself, so I've made an attempt here to do at least the first demonstration with a little bit heavier data and reached out to the field to acquire some of that. And so I hope that's appreciated. But that also means, please note that when I am going through the demos, I am pausing the recording every now and then to skip over the processing time just for expediency of the webinar. Feel free to ask questions. You can type those in anytime, and Sam is monitoring those, and I'll pause periodically to answer those. Okay, here's an overview of the webinar. I'll demonstrate how the modern architecture of QPS software enables and facilitates these advanced workflows that are very much unique to QPS. Starting with methods of smart processing that embraces automation. Our architecture also allows for this very easy project division and linkages amongst data types that really improve efficiency. And then finally, we highlight the great value in the integration of data acquisition software with the processing of bathymetry, water column, and multi-beam backscatter, all in the same infrastructure. So the result is a very seamless workflow that eliminates error and promotes efficiency from data collection all the way to the submission of deliverables to a hydrographic office, which will also be a focus. Okay, now I'm going to provide an overview of a workflow which is very befitting for today's hydrographic office. If acquiring data in Quincy, along with all the benefits of the real-time monitoring and QC functionality to ensure optimal data collection, you also have the benefit of the Quincy DB file, which is a very rich file format. And you can utilize the Quincy's real-time processing, which is essentially using your acquisition time as processing time. So this is by far the most efficient workflow because you're getting the process points, which are called the QPD files, in the bathymetric grid that's already prepared by the time you get back to the dock. For those who are not using Quincy, the workflow can still be very streamlined. There's a wide variety of raw sonar formats are accepted in QIMERA, which has the protocols to extract and utilize as much of that metadata as possible as a means of facilitating the process and eliminating human error. Non-Quincy users can still get their process points in bathymetric grid in near real time by taking advantage of QIMERA Live, which is compatible with all the same raw sonar formats that you see there that QIMERA uses. And so QIMERA Live is a directory monitoring function that will process any raw sonar files that are written to the specified directory. So next, the data goes into QIMERA. Here we do any required post-processing applications. The data is validated. QIMERA projects export to the generic sensor format, or the GSF, and in these files exported from QIMERA, they may include both the process data and the multi-beam backscatter all together in the same file. So next we use FleeterMouse for continued analysis, validation, and as well for the backscatter processing. The GSF from QIMERA is brought into FleeterMouse as source files and do not require any pairing, meaning that everything required to generate the backscatter mosaic is included in the GSF for a very seamless workflow. So that mosaic is created and exported as a GeoTIFF. Also in QIMERA, in addition to the GSF, you're getting the final validated bathymetric grid in the BAG format. You're exporting that, and as well the final validated S57 feature file. So altogether, the GSF, BAG, and S57 comprise a complete selection of survey deliverables befitting a hydrographic office. For example, NOAA in the United States, they specify GSF, BAG, and S57 as full and complete data deliverables for hydrographic surveys in support of nautical charting. There's extra benefit in that these are all open source formats, which is befitting for for archival at a charting authority. So next I'm going to go into a software demonstration. In previous webinars, we've already shown the great value in creating a project with a QPS DB file in terms of a streamlined workflow. But for this demo, I'm going to use a Rezon S7K data from two 7125 multi-beam echo sounders located on the port and starboard hulls of a survey vessel. And this is real hydrographic office data. It's the S7K data is relatively lean, so I have some pre-made vessel files that contain the lever arm offsets and angular rotations that QIMERA would normally read from the raw sonar metadata if it were available. And also the acquirers of the data were not using QIMERA Live, so I'll be creating the process points and grid in the QIMERA post-processing. So here we go. I've already created a project, and now I'm adding the raw sonar files. I'm just finding the directories of these S7K files, both for the port and starboard 7125s. So that's what I'm doing now. I get the directory there for it's a full day of 7125 data. I just give it this empty template, vessel template, and I'm going to overwrite that with my pre-made vessel file here that contain the offsets I need, and specify my coordinate reference system. And then as those are coming in, I'm going to do the same thing for the starboard 7125. And also you'll notice as these lines are coming in, you'll see the ENCs that I want to automatically display in the background. That's a nice function in QIMERA. I have a system path that's set to this the ENC base where I have all the NOAA ENCs, and so the correct ones are automatically displayed, and you don't have to retrieve those separately. So these lines are coming in now, and then the next thing I'm going to do, QIMERA has some nice ways to quickly organize your lines, really any of your data, and I'm going to, you'll see a lot of different options here. I'll defer the processing for now, and then I'm going to organize these lines quickly by vessel and by day. You see there's plenty of options, so I'm going to do that first. Okay, and now the next thing I'm going to do is, so this S7K data, as I said, it's pretty lean, and if there is sound speed profile information in the raw data, we'll use that in QIMERA. In this case, it's not. So what I'm going to do, I'm adding this separately. I'm using the SVP format. There's some concatenated day files I'm bringing in, and I'm tagging those to a vessel. And then let's go and do that again for the other vessel. QIMERA is not going to assume those both belong to the same vessel, so I'm telling it to apply to both vessels. There we go. And then I'm just going to adjust my processing parameters to a sound speed processing strategy. So here we go. So when you first, we don't want anything to get in the way of you getting to your map. That's a design principle of QIMERA. So if there's no sound speed found, we just ray trace using the surface sound speed. So now I've just imported my sound speed, and so I'm going to adjust that. I have timestamps, positions. I'll adjust that into a nearest and distance within time of 4 hours. And then so after that, we're ready to do the point processing, generating the QPD files, and we're doing that with our sound speed profiles that we just imported. And so if you haven't already done this, to validate your sound speed profiles, you can use the QIMERA SVP editor. I just double clicked on one of those profiles, and I have all my profiles plotted on the same set of axes, which is nice. And you can also eliminate anomalous data points from your sound speed right in there. So I'll be referring to this dialog a lot, the edit modified flags, which is showing you the processing that is pending in QIMERA. In this case, I've just applied the sound speed. That's why the sound velocity profiles box is checked. So that's the processing I have pending. And now I'm going to go ahead and build my process points using the correct sound speed by pushing that button there. Okay. So next we're going to build our dynamic surface. I'm going to just select all my lines and build a cube grid. QIMERA has the NOAA cube parameters that just come standard. So that's what I'm using right now. And so I'm building that. And then also, once that's done, the next thing I'm going to do is I'm just going to create some S57 features. And this is because I want to demonstrate QIMERA's connected S57 feature management. Okay, so when I create these features, I'm just going to create some rocks. They're actually not real rocks. I'm just doing this purely for demonstration purposes. As I create my QNC file here, give that a name, final feature file, But what I want you to see is when I create these features, they're going to inherit the value of the grid node that they're sitting on top of, which leads to exciting functionality where when your grid updates, all your features will update as well. So I'm just creating a rock here, and you see the valsal that comes right from the grid node that it sits on top of. So you can add whatever attributes you want or whatever your requirements are. We have the NOAA S57 attributes are there. And okay, I'm going to create a few more of these, but first, so I put some transparency on my grid, and yep, we can see the feature that's there. Or we can just choose this option to put the charts on top, which I just did. And the reason why I'm creating these features this early is again, just I want to show we're gonna be applying correctors, and we're gonna be putting everything to the ellipsoid and back to mean lower the water, and the whole time you can sit back and watch all your features update at the same time, which is extremely valuable. Okay. So next, we're going to be applying correctors. And so that gets to QIMERA's one-click reprocessing. And this is a major part of QIMERA. It's made possible by its unique design. Any changes you make to the processing parameters or any new correctors applied are very intelligently tracked. That's what you see here in the edit modified flags dialog. The level of intelligence is such that the correct sequence of reprocessing steps to be taken after changes are made is guaranteed with a single click. And we're taking that responsibility for you. This is unlike most any other software, which generally requires the user to program and design your reprocessing actions, and that can lead to errors. There have been cases of entire survey sheets or even entire projects where it was discovered much too late in the process that an incorrect sequence of reprocessing steps was performed. It's inherent in the architecture that the very design of QIMERA is made so that's impossible to happen. So these processing actions are smartly managed. So it's that kind of stuff can't happen. When you're ready to reprocess, it's done with a single click. Okay, and so before I jump back into the demo, I guess I'll go ahead and ask if any questions have come in, Sam.
No questions. Oh, actually, hang on a sec. We do have one question here. And it says, can we take the value of a sounding into the S57 or from a shoeless depth true position grid?
Absolutely. There's two different workflows. I'm going to touch on this later in the webinar. You can create a feature directly from a least depth sounding. Absolutely. That's something that we will always maintain because there are instances where you definitely want to do that for safe navigation. So the other way that I just did it now is taking the value straight from a grid node, which is a little different philosophy, but I think they both have value. So I'll touch on that more later. Okay.
Perfect.
All right. Thanks, Sam. All right, getting back to the demo here. So next, I'm going to apply some smooth best estimates of trajectory processed in a Planx to the data. So this is going to reference all my data to the NAD83 ellipsoid, both vertically and horizontally, while also improving the internal consistency of the data. So to do this in QIMERA, I'm just going to select the SBET that applies to a group of lines. I'm going to do it for both the port and starboard side because they both have separate SBETs because they both have their own IMU in each hull. So I'm selecting the port one first, and now, so in this menu here, what we have is, this is how we import a binary navigation file. So if it's a bunch of POS files and you're doing the delayed heave, that's a motion system reference. You'd have the option to extract true heave, but it's kind of the same process, similar process. In this case, the SBET, I'm going to overwrite my position and my height. So this is a position system reference, and so I'm creating a new system to represent the SBET. And then so what we do here is if we already had a place in space already configured, then we could just simply copy those values from an existing system. That's just to prevent you from having to punch in numbers. So, but in this case, the SBET's derived from the IMU, which is the reference point, which means this is all going to be 0, 0, 0. And all I got to do is give this thing a name. So I call it the port SBET and say OK. And then I'm just going to ensure the proper GPS week, the coordinate reference system, and then I'll specify that I'm extracting position and height to be the primary sources for these files. There it is. Okay, and then I'll do the same thing for the starboard side. You see the processing's pending here. That's what These are little indicators, meaning that those have processing pending. Select the day. Select the vessel, the starboard side, and then I'm going in here and giving it a name. Extracting position and height. Again, yep, a coordinate reference system, then we're off and running. Okay, so now that's loaded. I'll defer the processing for now just because I would like to check the modified flags, check the processing that's pending. So I applied the SBET to overwrite position and height, so those are both checked. But now let's say, just for instance, we weren't happy with our sound speed application. We want to go in here and adjust our sound speed strategy. And say we want nearest and distance within time of 3 hours. We think that's going to work better for us. So now we made 2 different post-processing changes. And so let's go back and look at those modified flags after I first will apply these to the starboard side as well. This change. Nearest and distance within 3 hours. We check our modified flags. Okay, now we see, so we're still pending the SBET application. Now we're pending sound velocity correction. So now normally here is where I'd freeze and be like, okay, what do I need to do first? So this is the real value in QIMERA. You can make as many changes as you want, and then when you are ready to apply everything and go, it's just the one click. So I'm going to select all my lines, and this is the button right here for the one-click reprocessing. There it is, and then we can be assured that our lines will be up to date. And also look down here, all my features have jumped to the ellipsoid. Before they were between the 19 and 20 meters or so. Now they're up between 57 and 60. So that's nice to have all those update automatically. So I'm at the NAD 83 ellipsoid now. Okay, moving on. So now we want to shift everything, our vertical referencing, from the NAD 83 ellipsoid to mean lower low water. And to do that, so I have a VDatum separation model that was as a bag. I have it as a bag. To use that in QIMERA, I import the bag, and when that's imported into QIMERA, it becomes a SD object automatically. It's converted to an SD object, and that's what's applied in QIMERA. So that's what I'm doing now. I'm bringing this the bag in. I'm specifying the input and output coordinate systems. And so there it is. I'm going to zoom out a little bit so you can see the separation model. And so I could have applied this. I could have lumped this in with the processing earlier, but I wanted to do it separately, mostly so you could see the features update automatically. But so that's what we're going to do next, is go back here into our processing parameters and apply the separation model. And so you can see in our position tab, we have the port SBET as priority. For vertical referencing, we have the port SBET as priority. And I click this box for separation model, select that SD object that was just created, and say okay. And I'll defer the processing for now and then do the same thing to my starboard side. Okay, and now I check my modified flags again. I do that a lot here, and I see that I'm pending a vertical referencing. So now we're ready to go. I'll just select all my lines and do the auto reprocess. And now watch your val sals down here. There we go. We're back to mean lower low water. And then so I've now, after the application of the SBET, it's good to look over my grid here, and we can see the internal consistency has improved, and that's what I'm doing now, is just kind of giving it a look over. Okay, and so now the next thing we're going to do is some point editing. But first, I'll tell you about just a little bit about the spline filters. We've shown these before. Just want to emphasize that they're highly customizable for rapid data cleaning, and you can also get much higher confidence in your grid if you do the data cleaning, and have more confidence that there's no grid flyers. Stuff like this, generally that's 1 or 2 clicks, So it's just very fast. Now Cube can take care of a lot of that for you. So, but if you do want a fully clean data set, this is a fast way to do it. So that's what I'm going to show next in the next demo. I guess I could pause again and ask if some more questions have come in.
Yes, Matt, there's a question now about the NOAA, what are the NOAA standard Cube parameters and what type of bottom is assumed?
What type of bottom is assumed?
Yeah, so, and I guess that we could probably clarify, and I think they're asking, is there a particular type of bottom assumed with Cube? And then what are the standard Cube parameters?
Okay, yeah, it's based on resolution. They used to be based on depth, but yeah, in recent years, the Cube parameters are based on resolution. And so there's just a system file in QIMERA that specifies those. So that's the best I can speak to that right at the moment. But if he or she has more questions along those lines, we can talk about that offline.
Great, thanks, Matt.
All right.
There's actually a couple more questions, Matt, that came into.
Okay.
Yeah, it says, will QIMERA tell you if no SVP is included in the imported files?
Yes, it does. There's a little warning, and I could have pointed that out when I first was bringing in my lines with no SVP, that it was ray tracing using surface sound speed. There is a clear warning about that because obviously, that's, especially in deep water, you definitely want to get the sound speed profiles in there. So yeah, there is a warning about that.
And then there's one last question is what software created the bag file, and can it be done in QIMERA?
Absolutely. We're creating bags in QIMERA, and we're going to do that at the end of this webinar. That particular bag I received from my colleagues out in the industry, so I'm not sure exactly what software they used. Okay.
Okay, that was the last of the questions. Yep.
All right, thank you. All right, I'll jump back into it. And so first I'm going to use a different layer of my grid here and just adjust the color map, which maybe we might be able to see where there's some noise better. Again, if there's different ways to approach this, you could just, use Cube. And, a lot of this noise is not Cube is smartly circumventing most of this noise. But if you do want a fully clean data set, that's what I'm doing right now, is just going in here and cleaning out these side lobes and so forth. You could also just be using the grid to do this and looking where there's flyers. I'd recommend doing both of those. So that was just one click, got rid of most of that, and then I finished the rest off. And now I'm moving along. And so this is how I like to clean data, in using this 2D slice editor and with the spline filters is it's really fast. And but later I'll show you how you can use the 2D and 3D views at the same time. I'm going to do that. But this is generally just one click as we're moving along here. So it's pretty fast. You can use Control-R anytime you want to see the rejected soundings. And there's always an undo button if you think the filter was too aggressive. So it's good functionality. And then there we go. There's a one-click one. Then we can also use the surface edit overview there in the bottom left. I'm about to bring that up, and so that's tracking where we've been, which is nice. Yeah, there we go. And of course, it's always nice when you have multiple monitors to look at this stuff. So, but I'm just going to zoom in here, and so the white color is where I've been, red is where I've edited. So that's how you can pretty easily track. There's some other functionality in there to nicely kind of break it up. And so yeah, that's what I'm doing right now. But it might be useful, say you had several people that want to do this kind of work. And so normally only one person can be working on this project at a time. That's what I'm used to. But we have this real nice method to easily break this thing up to allow for multiple data processors. So that's what I'm going to get into next year after I'm done doing my slice editing. Notice the surface is updating as I'm moving along here. Okay. So that's good. That leads us to, it's called cooperative cleaning. That's the name. You can easily divide the project for improved efficiency. And so, yeah, you can break it up. And the key thing is the projects are fully self-contained. So you can send the sub-projects anywhere. So here's how I look at it. Like, you have your master project on a network with a survey chief who maybe is in charge of all the the mathematical processing, things like, applying the SBET, the sound speed, the tide. He or she's in charge of all of that. And then for the validation, the real time-consuming stuff, that you can parse those out into multiple projects quite easily and send those wherever you want, these cleaning projects, including locally. So this has a real nice advantage, because there's, you're not constantly writing over the network when you're editing. There's only 2 network transactions, one at the beginning, to push all the data down, and then one at the end to push all the edits back up, instead of the constant network transactions all day that bog down the system. And very often that's kind of the limiting factor in a workflow. So this nicely circumvents that. So I'm going to show that next, where we have our surface. I'll bring this back to the depth layer, zoom out a little bit, and we're going to break this thing up. So we go here to our project tab, create cleaning projects, and we give it a name. I'm just called it cleaning project. And then, so we could put this anywhere we want. We could put it on a thumb drive. In this case, I'm just putting it right next to my master project. But so then, depending on how many people we have 2 people or 3 people, 4 people, in this case 5 people. I'm cutting this into 5 projects. And so yeah, these projects are fully self-contained. They have the QPD files and the grid that they need to do the slice editing that I was doing and the filtering and all that. So I just closed my master project. Now I'm going to open one of these cleaning projects. I think I just choose the one at the top there. And then so we'll give this a second to load. And I think this, yeah, it's the bottom segment of the master project I was looking at. There it is. All right, and then I'm going to zoom in here, and we'll switch to a different layer of the grid to kind of guide where we might want to look. Adjust the color map. And we'll zoom in here, and I'll do a little more slice editing. Some side lobes there. And so in the meantime, that master project, they can still be doing the processing that's necessary. And then these edits are just going to come in with a simple flag to either reject or keep the soundings. So that's how it works. These things are happening simultaneously. So it's a very efficient workflow. You see there's some refraction in this data too. So I'm using Control-R to see the rejected soundings. And then I'm just gonna move along here, do a little more slice editing with the filter. And then eventually what I'm gonna do is I'm just gonna purposefully make a goof in the data and just cut a big hole in the seafloor, just for demonstration purposes, so you can see how, not only are my edits gonna go back to the master project, but any mistakes I might have also. And then the survey chief can validate that. So it's, give this a second here. Yeah, here we go. I'm cutting a hole in the seafloor and turn off my rejected soundings. And we see there's a hole, and then the grid's gonna update. There we go. I have a hole in my grid. That was totally, we'll pretend that was unintentional. Obviously, I wouldn't want to do that. And now what I'm going to do is I'll close out of my cleaning project after taking a look at this thing here. I close out of this project. I'm going to reopen my master project and push those edits back. Just give it a second here. There we go. And now it's just under the project tab. There's an option for apply cleaning project edits. There it is. And I select the cleaning project I was just working on. Say OK, and then give it a second as it's loading here. And there it is. There's a hole in my grid. Well, all my edits have updated, including ones that were unintentional, such as this. So now the survey chief is going to validate the work, and they're already not too happy when they see that. They're also really not happy because they see 2 flyers in here that were totally missed. So the survey chief's going to take care of this. they're going to go back and actually just going to lasso this and just going to try to kill it with our spline filter, but it's actually a pretty legitimate side lobe, and ultimately I'll just go into our slice editor to take care of it here. The 2D slice editor. There it is. So I'm showing the rejected soundings. You see it's a pretty heavy side lobe, so the spline filter didn't get all of it, but I'll finish off the rest of it here. And then we'll watch the grid update. It's a very tight coupling between the QPDs and the grid, so it's very rapid grid updates. Now I'm just going to lasso that hole and just adjust my filter to accept all soundings in there, just to bring that data back. And then give the grid a second to update here, and okay, there it goes. And now I'm going to take a look at this spike on the other side, and I'm going to do a little more slice editing, but this time when I do it, I'm going to show you how it's really nice functionality where you're getting the 2D editing with the 3D view in the same time. You have the context of the grid, and it's really customizable. I'm using the shift key to adjust my view there in the scene. And that's an important thing to know about, because you can adjust the view any way you want. It's very much customizable. You see there's these strong side lobes in here, and I'm going to put my spline filter back and run that. And just going to move along here and do a little more editing. And again, you may not even need to do this, because yeah, well, you had to do it when you saw the spike, obviously, but you could also just validate the grid, and maybe you can live with the noise, but maybe you want a fully clean data set just to be totally safe, and so you're going through this. And again, the spline filter lets you do it quite quickly, and you have the nice 2D view with the customized 3D view there too. And we're seeing some refraction in here too, which caught my eye. We do have a new refraction corrector called from TU Delft, which was introduced in the QIMERA 1.6 webinar, and which works really well. It's really automated and easy to use, perfectly reproducible, the results. And I actually might run it on this data set right here. See if we can fix that. Okay, so let's move on. So now let's just say we've finished and we've validated our data. Let's say we've done all of our feature management, and so what I'm going to do is take my my QNC feature file. If you want to see about how we have methods for S57 attribution and using sub filters and so forth, we also have our ENC S57 webinar. In this case, let's pretend I've done all that. My final feature file is done, so we're exporting this to an S57 file. It's going from the QNC to S57. That's what I'm doing right now, and you can give it a name, file name per your agency requirement. I just called it final feature file for now. Let's say we've also finished validating our grid, and so this exports to a bag right here. So that's what I'm doing now. Again, you give that a file name. Normally this would start, I'm used to this starting with a registry number, and then something like multi-beam, mean low water, and then the resolution. And so there we have our bag. And then you can enter in the bag metadata, per your agency requirements. And also the QIMERA projects, as I said at the beginning, these export to GSF. So that's what I'm going to do now. And then this is real nice, as I said earlier too, you have the option to include the backscatter either in the water column or the snippets on the seabed. So that's what I'm doing now. So that's for the seamless import into FleeterMouse Geocoder toolbox. Okay, now I'm going to look at what I've just exported. Control F brings up your folder window here, and you see in here I have in my exports, I have my bag, my S57, and in those folders I'll have my GSF for data deliverables there. Okay. All right, and then so I'm going to do one more shorter demo using a different data set, and it's one we've seen before. It's I'm going to look at some water column data, but I'm going to create a feature from the water column data. And it's going to be linked to the bathymetry. And this will answer one of the questions we had earlier, because I'm going to demonstrate that process. Link the feature to the bathy, this time to a sounding, not to the grid. Although it's customizable, I think both ways have some nice advantages. So this is what it looks like. Like if this was in shallow water, this could be dangerous. The grid appears to be doing a poor job encompassing this rock, and you might actually want to choose a finer resolution. But also you could get the least depth here, and then you're creating that into an ENC feature automatically in QIMERA here. And the valsow comes from that least depth sounding, and we're also having these unique QPS S57 attributes linking the feature to a beam, ping, a line, and a system. And then you check that box to set a custom hypothesis in Cube. And so in this manner, we have sounding, feature, and grid all in agreement, and any processing is going to update all three and make sure they stay in agreement. So that's real nice. Alternatively, there's the grid just snapping up to the feature there. Alternatively, if you had this situation where we're in 44 meters of water, this is a rock, you could make the argument it's not necessary to go in there and create a feature from the least depth. You might even argue that the gridded estimate of the least depth is a much better estimate anyway. So that's why we're supporting this other workflow where we're creating a feature right from a grid node. So, and in this workflow, you have these attributes that are linking the feature to a dynamic surface and to a particular layer of the dynamic surface. Okay, so I'm going to show that, and also at the same time, the value in the integration, the water column processing, where we're easily attaining safer least depths atop wrecks and obstructions, and then a very seamless workflow for the backscatter processing with the GSF and FMGT. So I can jump into that, but I guess maybe one or two questions if those came in?
Yeah, Matt, there's actually a question about the cooperative cleaning workflow.
Sure.
So the question is, does QIMERA cut the QPD files to the sub-project bounds?
Does it cut the QPD files? I know it cuts the grid. The actual QPD files, if you were to re-grid that, I think it takes the full QPD files, but I don't want to misspeak. So maybe that's something I'll come back later and make sure I'm giving the correct answer. But I think it takes the full QPD, but cuts the grid.
Yeah, that's my understanding too. But we'll follow up with the participant after.
Okay.
Thank you.
All right, thank you.
And actually, there was one more that was right before that. I just caught it, sorry. And the question was, is it possible to export the surface overview edit areas as a polygon or shape file?
I don't believe so, although that's a real nice idea, and I might go ahead and jot that one down. To my knowledge, there's not.
And there's a second part to that question, is for QC down the line in a master project / validation.
Yeah, so my understanding of that question is what they want to do is be able to export the surface overview area as a polygon or shape file, so that they can then use that shape file or polygon for the QC in the master project, which is a really good idea. As Matt said, you can export the surface overview edit area, but only as an image, so a JPEG or PNG, a TIFF, an EPS, and not currently as a polygon or shape file.
Okay.
Yeah.
All right, thank you. All right, so I'll jump in here to the last demo where I'm just going to create a quick project here in QIMERA. This is a shipwreck. I know it's one we've used before, but we have the water column backscatter available, and so I'm just going to give this, or I'm just pointing to the directory where we have the Kongsberg all files, and give this a second to process, and I'll create a quick 50 centimeter resolution cube grid, again using those NOAA cube parameters, and give that a second. Okay, there we go. So immediately I see there's at least one flyer there along the bow, which I just want to take a look at that before I do anything else. And so I'm going to use our 3D editor for this. Usually for my data cleaning, I like to use our slice editor with the filters and using the 3D and the scene. This is where I go to ask questions like, is this thing real or is it noise? You have the context of the grid with the soundings, and also you can query attributes on the soundings and really get good answers to those questions. In this case, it's just that's pretty obviously noise there, and this may be a little subjective. I'm going to cut off some of this other stuff too, and then hopefully that'll at least take care of the flyer that I saw. And so I'm going to get out of here. And, okay, it did, and then I'm just going to jump into the water column data. First, tip it in 3D. And so we access that in our swath editor here. And I'm going to just go over the bow and click the water column tab. And so there's a single ping of water column data. And then it's a really nice workflow. And this is new as of this year, where we can get a view, a side stacked view of the entire line. And so this is a real nice way. We just a nice method. We get the side stacked view of the entire line. We put it right in the scene. And so it's a real nice way of quickly seeing any targets that are in the water column along your entire line. This was introduced, or there's the QIMERA 1.6 webinar. Dr. Jonathan Bodewin did a really nice demo of this, where you can quickly find things in the water. In this case, I see right away, there's a mast that may not be properly encompassed by the multi-beam bottom detections, at least not as well as we would like. So I see where that's at. Now I'm going through the pings to try to find this mast. There it is. I see it pretty well there. And then what I'm going to do is just filter, or I'll take a picture of it first. Hold down Shift to pivot my scene. And so there's the fan view there, where we do indeed see the mast. And so I want to get this, for safety navigation, I want to get this in, so it's encompassed in my bathymetry and in my feature file. So I'm going to create a quick filter to my acoustic intensity here and just kind of slide that thing around so I feel like I've kind of nicely isolated the mast. Could be something like that. And then I'm going in here and zooming in for a closer look. And I'm just going to convert the whole mast into bathymetry. I'm just going to lasso all these soundings. It's a kind of quick and dirty work I did here, but just lassoing the whole thing just to show you how it's done. And then when I exit out of my swath editor, I have unsaved new soundings. I'm going to convert these water column picks to new soundings, and we see right away in my grid I have a prominent mast there. So that's a good start, but now I want to go in there and fine-tune that even more, and select the least depth sounding and create an S57 feature again, this is to ensure safety of navigation on this thing. Again, using my 3D editor. Tip that horizontally so I can see it. And so those spheres, those are my user additional soundings, are what they're called. And it means my water column picks. I'm going to color those this kind of pinkish red there. So those are the picks that I just added. And now we'll have a closer look here. I'm going to turn on the surface for additional context. And ultimately, I'm going to choose the cube layer to display. There it is. Okay, so we see cube is doing pretty well, but again, for safety and navigation, I want to get the least depth on this thing, at least from the soundings that I brought over. And so we have this utility to automatically get the shoal depth, but it was noise that I just rejected. Now I just got the shoal depth on the mast. You see it has crosshairs on it. There's a button to create ENC point object. I click on it. I'm going to create a new ENC layer. I call it my default name, final feature file. And so it has the valsal already there. I'll tag this as a rec object, dangerous rec. And so it has the attributes linking it to the bathymetry. Then choose your agency requirements for S57 attributes. I got the NOAA ones there, remarks, recommendations, and so forth. Say OK. And yeah, I mean, you could fill all these out. I think I just changed the watt lev there, so it's always underwater. And then the last thing I want to make sure to do is check the box for the custom hypothesis, just to lock in the grid as well. There we have our three-way agreement is achieved, and then we can exit out of here and save it. So there we go. That's yeah, safety navigation from the water column there. And now the last thing I'm going to do is I'm going to quickly export my files to a GSF. I'll do that in the next slide here. Oh, I just brought the feature file on top so we can see the feature that I made, and added a little transparency to my grid as well. There it is. You can see it real well now. Okay, I'm just gonna quickly export these to GSF, including the backscatter. Find where they've exported to in my project, and I'm just going to run these through Fleeter-Mouse Geocoder Toolbox. And this is just to show, again, to show you our vision of making this really seamless and in creating a backscatter mosaic in a very simple, seamless way. And okay, I'm just giving this project a name. And then we'll add these as source files. Okay. And so give those a second to come in. And so you have a recommended resolution there. I'm just going to adjust that to a 0.5 meter, and then let that go. Build our mosaic here, and then just adjust the histogram, and then just export that to a GeoTIFF. All right, and then the last thing I'm going to do is I'll just bring that GeoTIFF back into QIMERA. By just importing the image. And then it's nice to have the context of the bathymetry and backscatter together. Put some transparency on one of them. There it is. Okay, so that's the end of that demo. Okay, and then there's one more slide that I did. We noticed some refraction in that project in the first demonstration here, and I couldn't help. I had to go and try our new sound speed inversion algorithm, and yeah, I just did this at the last minute and noticed that. So here was the effect. This was the exact same area I was editing, and I used that, and so you see it worked pretty well. It really got a nice result there in this little area. So this may or may not be part of your workflow. I know we have some people that are very, very interested in this, but it might vary per hydrographic agency, but I just wanted to show that because I thought it was interesting. And if you want to see more on the TU Delft sound speed inversion, that was also included in the QIMERA 1.6 webinar and demoed by Dr. Jonathan Bodewin. Okay, that was it. So thank you all very much for your attention. If some more questions came in there at the end, we can address those now, but thanks a lot. We appreciate you tuning in.
Yeah, Matt, we actually have a good S57 question.
Okay.
And the question is, can we update or read the S57 from NOAA S57 attributes updates? So
as the so every year those attributes get updated. Specifications change, or different attributes might change. So yeah, that's something that we will need to maintain every year, and working with NOAA in making sure those get updated. There is a level of it's fairly easy to customize those in QIMERA, as I understand. So, but that is some maintenance that we'll need to ensure that we're up to the latest version of the NOAA attribution. I hope I answered that correctly, but if not, they can follow up. Just send me an email.
Great.
Okay.
And that looks to be the last question.
Okay, good. All right. Well, yeah, thanks again, everyone, for tuning in, and we'll be following up. This webinar will be posted, and as well, yeah, we'll be following up. And if folks are interested in evaluations or just want some more information, then yeah, please keep in touch. So that's all I got. If Sam or Chris, if you have anything you want to add.
No, thanks, Matt, and everybody have a great weekend. Enjoy your 4th of July if you're in the States.
Yeah.
Thank you.
Okay. Thanks, everybody.